So this particular example here, taken from one of the exercises, I wanted to have a look at because it points out one or two important things. First of all, the idea of having a fraction where I've got two things added together and something on the bottom. If we think of, remember a squared b, a and b are numbers, so a squared times b is a number, and so is a cubed times b. They're numbers. So 3 plus 2 over 7, for example, could be something similar to this. I've got two things on the top added together over something underneath. I can split this into 3 over 7 plus 2 over 7, because that means the same thing. So 3 plus 2, which is 5 over 7, is the same as 3 sevenths plus 2 sevenths. That's a useful thing to remember to do with fractions. The 7 is effectively distributed, division is distributed over the two things on the top, the 3 and the 2. We can use that here, because I can write this as a squared b over a squared b squared plus a cubed b over a squared b squared. And that's a crucial first step. I can't do any combining of using laws of indices. I can't cancel anything top and bottom, and if there's something added on the top. I can only cancel if there's just one thing top and one thing bottom. So the first step is to split this into its two parts like that, and that's an important thing to remember if we're going to try and simplify something like this. Now I can say, using the laws of indices and combining the a's here, a squared divided by a squared, 2 minus 2 is nothing. So that just cancels out to give 1, because anything to the power 0 is 1. So the a's effectively cancel out. B's, I've got b to the power 1 on top, minus b to the power 2 is 1 minus 2 is minus 1. So I've got a to the 0, b to the minus 1, plus 3 take away 2 is 1 for the a's, so that's just a. 1 take away 2 is minus 1. So minus 1 means the inverse. A to the 0 is 1, so this becomes 1 over b plus a over b. Now it is worth thinking about writing it like this as opposed to using these powers. Now when I add fractions together, if the denominator is the same, in other words, I'm looking back to this, both 7s, I can just add the top numbers at 3 plus 2. In the same way, common denominator is b, so I can actually simplify that to be 1 plus a over b. All of that initial problem simplifies down to 1 plus a over b. So we're combining using the laws of indices with knowledge of fractions to do a question like that. So we get this answer, 1 plus a over b, using these laws of indices here to arrive at this. However, there's another way to think about this, and this is perfectly acceptable to do this. Again, to do this, you must split it into its two parts, the two fractions. But there's nothing wrong now with saying a squared, 2 of the a's on the top, cancel with 2 of the a's on the bottom. So this is like a times b on the top over a times b times b plus 3a's over a, b, b. Think of it like that, or even write it like that, because then we effectively are cancelling a's top and bottom and replacing them with 1's. So these two cancel out effectively. One of the b's, the b on the top rather, cancels with one of the b's on the bottom, So this cancels out, leaving just b on the bottom. So I can cancel out the squared, and this is something you can do with practice. The second one, 2 of the a's on the bottom can replace with 1s and replace 2 on the top. So that just leaves 1a on the top. And b's on the bottom, 1 of the b's on the top, bottom either cancels with the b on the top, leaving just b on the bottom. So this then equals 1 over b plus a over b, which is the same as we had before. So you can think of sort of cancelling out top and bottom by thinking of it in terms of what it means. Okay?